what else is this sculpture just dying, begging us to measure? What is the first thing you're curious about when you see the sculpture? The height. How tall is that thing right there? Okay, super. So we'd love to get some way, and like my tape measure, I've got a pretty good tape measure here, but this method of, going up in the air is gonna suffer some problems pretty quickly, like that. So, all right, I need something cleverer. Anybody have a mathematical idea that could help us get a handle on just how high that point is way up there? Some kind of a mathematical principle that will let us leverage measurements that we can make down here to measure something that's totally out of our reach. Shadows, right? That's how, you may have heard the story of Eratosthenes measuring the Earth, right? That's how he measured the Earth, by using shadows. He was able to measure the entire Earth by doing measurements on the ground that he could work with. Excellent idea. It's not very shadowy in here, is it? I mean, this place is just too well lit for shadows. Unfortunately, great idea. Any other thoughts of what?
Estimate the drop-down point. You measure to the point where it's going to intersect.
Absolutely. So we're going to use a method, which is a classic, called similar triangles. So, Oh, yeah, right. So the suggestion is that we find the drop-down point, measure across the floor to the back leg. We know the height at the apex, or at least approximately know the height at the apex. And then we're going to use something called similar triangles to find the height. And I had an eraser for this, but it seems to have disappeared. Nobody has a tissue or a... You sure? You positive?
It's got snot all over it.
Oh, well, excellent. Nice, clean. All right, I'm gonna need that again, I promise you. Okay, so, that's not the right pen. This is the right pen. Okay, so now the diagram, it's a real angle diagram. This point here is the back leg of that. And here's an imaginary line along the floor. Here is that center point that I modeled. And here's this beam going way up here. And I know this height because I measured it, or at least I know it approximately. I got 190 inches. I also measured this distance, and I got 104 inches here. So if I could, sort of wander around until I feel like it's right above my head. And actually, a good way to tell when it's right above your head is if you spin in place with your head straight up and it doesn't seem to move, then you're kind of underneath it. If you're not underneath it and you look straight up, it'll seem to move as you spin around. So that's a little check you can do. So once I found that spot, I could then measure this distance right here. And what the proportionality says is that 190 over 104 is going to equal to my unknown height h over this distance. What I actually did is I measured this one here. That was 180 inches. So adding those two up, I get 284. And now you can all whip out your calculators if you like. I would get that h is equal to 284 times 190 all over 104. Anybody have a value for me? If you got a calculator in your pocket like many of us do these days, how many inches high? Shout it out if you hear it. I mean, if you figure it out. Oh, yeah, the numbers. You need the numbers. Okay, what do you got? Okay, so we'll call it 519 inches. How many feet is that? 519 inches. Well, it's about 20, and there was a little 30-something, about 23 feet high. Did I do that right? 43, right, because 12 into 50 is about 4. 43 feet, about 43 feet. Okay, now we have the moment of truth. I have not looked at this document. We have a document. Where is the document? The document is here. we have a document from the art program here. This is the North Park Art Tour, and this is item number 1 on the list. Who would like to look up and check our estimate of 519 inches here? All right, go right ahead and look up number 1 and tell me how many inches tall is that object. Okay, 576 inches. So our model said 519, actual 576. I'm within 10%, just doing some simple measurements. That's not too bad. I thought mathematics was supposed to be exact and give you the exact answers. Well, in our model, the exact answer is 519 inches, but mathematics always is something that we use to model the real world more and more closely. The closer we can get, the better. But we already know from our first calculation that there's some discrepancies between the model and reality here. If you even look carefully, you'll see that this beam here and that beam there are not the continuation of a straight line, which our little model there assumed. So we're going to be off, but nevertheless we do pretty well and can get a pretty good handle on something over 40 feet in the air just doing some simple measurements down here on the ground.